So today we're doing more complicated circuits. So complex circuits, what I mean by this is we have resistors both in series and in parallel. The main thing to do in this situation is if you have two resistors, say, in parallel, create or you turn them into one resistor. So you find the equivalent resistor if it was just one resistor. So you're basically breaking the problem down into small sections. So we've got an example and it wants us to calculate the potential difference and the current across or through each resistor. So a good step to start with, if you have something like this, as I mentioned previously, is to just look at the two parallel resistors, right? How do we find the total resistance if we have two resistors in parallel? What's the rule? So that's the formula if you have two resistors parallel. So what's the second resistor's resistance? 30 ohms. What's the third resistor's resistance? What's the common 120? So multiply this one by 4. Multiply this one by 3 to get the same denominator. So you end up with 4 over 120 plus 3 over 120. Okay, so we find that the total resistance, if we now flip both fractions, so this is equal to 1 over RT, flip both fractions, you get 120 over 7 ohms. Okay, so now if you redrew this, it would look a bit like this instead. 20 ohms, 120 over 7 ohms, 10 ohms. Yes, the next step is to add them all together. So the total across the whole circuit is R1 plus the one we just found, 2/3, yeah, let's call it that, plus R4. So it's 10, 10, plus the one we just found, plus 20. So we're pretending there's 3 resistors in series right now. Does that make sense? Even though there isn't. So 12 volts in the diagram. And we don't know the current. We just calculated the total resistance. So on your calculator, what's 12 divided by that number? 0 point something. Okay, so that's the total current. Now we know the voltages are shared when it's in series. So now we're going to use Ohm's law again. V equals I times R. And we're going to find, let's do it for resistor 1. So we're subbing in the total current. And what are we using for R? For resistor 1? 10. So that's the voltage across resistor 1. About resistor 4. What are we timesing the amps by this time? 20. So we're subbing in the resistance. Okay, so now we're pretending resistor 2 and 3 are one resistor. So we're going to find the voltage through that one. So it's the same current. So let's call this 2/3. Now we're looking at resistor 2 and 3 not as one. So they are separate resistors, but we know the total voltage going through these two resistors is that. It's not 12, it's that. Okay? So we have Ohm's law again, but this time, because they are parallel, the current splits, or the current is shared, but this total voltage here is the same across the two resistors. Okay? So this is the volts across resistor 2 and resistor 3, which are parallel here. So we don't No, the current. What's the resistance of resistor 2? So we sub in 30. So we do 4.3629 divided by 30. So that's the current in resistor 2. Now we're going to do the current in resistor 3. So that would be the same total voltage divided by 40 this time.